This question talks about a man on a ledge jumping down to the ground. So there's the ledge. Here's a bad stick diagram of a man with his legs almost straight, which is typical of physicists. They just abstract whole objects as points, so we're just going to consider him as a point particle. He's going to jump down and he's going to land just where his feet first touch the ground there. So we're going to abstract him as a point particle there. And this difference in positions, I guess we'll call, let's lay down a set of coordinate system. Let's lay down a coordinate system right here. There's y, there's x. So he has some kind of final position. He has some kind of initial position. And the difference between these two positions is the height of the ledge. There's the ledge. He stands above the ledge. When he leaps, he stands above the ground when he lands. And there's going to be the difference between the change in height is y final minus y initial, and that's equal to the height of the ledge. That's given here. The height of the ledge is about 3 meters, for at least in my question it is. The mass of the man is given. And the part A asks for, what's his speed? What's his final velocity when he just touches the ground? When his feet first touch the ground, what's his speed at that point? Well, what's his speed at the beginning? We're assuming he's just standing at the ledge, so he's not running off the ledge horizontally, and he's not jumping up, or you can't jump downwards actually. You can only jump up or just let yourself fall. So his initial velocity is 0, and we know his acceleration. Acceleration is acceleration due to gravity downwards. Downwards will be signified by a negative if we consider up positive. Downwards will be negative. So we can use, this is a kinematic equation. This is a kinematic question. Kinematics. This is one in a straight line, no circular motion here. So we're going to use, how about velocity final squared is equal to velocity initial squared plus 2a delta x. And for us, delta x is going to be delta y. We're talking about the vertical direction. Velocity final is what we want. Velocity initial is 0. The acceleration is negative g, which is negative 9.8. And our change in y, that's this h. This is y final minus y initial. That's how far he jumps down. That's the height of the ledge. So I'm just going to put h in here. You guys have values for h, you know g. We're looking for the final velocity, which that's what we don't know. The initial velocity was 0. So the final velocity, using the algebra, is, now let's look at this. Let's be careful. Change in position. Y final minus y initial. Y final is a very small height. Y initial's a very large. So his change in height is the final minus the initial. This is actually equal to negative h, because his position was a change in the negative direction. So we'd have to be careful with the sign here. This is not h, this is actually negative h. Because the it's a change in position. And his change in position was from a high position to a low position. Final minus initial, that's negative h. Alright, anyway, it's the square root of negative g, negative h, 2gh. Alright, so now you can figure out how fast using a kinematic equation how fast he's going to hit the ground.